So today, we're going to be learning about the volume of cylinders. Please pause the video now and gather the following materials. So today's objectives and some vocabulary for today is that we want to calculate the volume of cylinders. We want to determine how changing one dimension, such as the radius of a cylinder, affects the volume. Some of the vocabulary we want to keep an eye on is volume, cylinder, radius of a cylinder, and height of a cylinder. So, before we dive right into it, let's go over the history of cylinders. The first scrolls regarding cylinders were dug up in 1879 in the Ottoman Empire, or present-day Iraq. The scrolls were written in Babylonian by the orders of the Persian king Cyrus the Great, which we think happened around 539 BC. Now that we have this overview, let's go over what a cylinder looks like. So, for this lesson, we're going to be discussing only right cylinders. That is, a cylinder whose base, shown in the white here, lies perpendicular to the altitude or the height of the cylinder, forming this right angle. The formula for finding the volume of such a cylinder is pi times the radius squared times the height, or the altitude of the cylinder. At this point in the video, please grab those materials that I mentioned earlier. For the first step of this activity, we want to create cylinder A. On our white piece of paper, we want to label it with a giant A. Next, we want to roll the paper so that it forms a tall cylinder, shown in the bottom right picture. We do not want to overlap any sides, and then we wish to tape the edges together. Our second cylinder follows the same process. We want to label this colored piece of paper with a giant B, and then we want to roll the paper in a similar fashion, but have the opposite sides touch, that is, making a much wider cylinder, also shown in the picture below. Now we want to take our ruler and do some measurements on our cylinders to collect some data. We want to take the height of cylinder A and cylinder B, the diameter of cylinder A and cylinder B, and the radius of cylinder A and cylinder B. Now, we don't have to formally answer these questions, but we want to bear them in mind. Do you think that the cylinders will hold the same amount? Do you think that one may hold more popcorn than the other? And why? So, now is a time where we actually do the activity. We want to take cylinder B, that is our wider cylinder, and place it on our plate with cylinder A, our taller cylinder, inside of cylinder B. We want to get our popcorn, and we want to pour our popcorn into cylinder A until it is completely full. And for our final step, we want to lift cylinder A so all the popcorn falls into cylinder B. Is cylinder B completely filled, even though cylinder A was? And what does this conclude about the two cylinders made out of the same piece of paper? Do they hold the same volumes? Now, being that we already have the volume formula for a right cylinder, let's actually try to find the volume for cylinder A and cylinder B. Recall that the formula is that the volume equals pi times the radius squared times the height of the cylinder. Recall the data table that we made earlier. We reach our answer that cylinder A has a volume of 67.7 cubic inches, and cylinder B has a volume of 86.5 cubic inches. Now, for the final question. How can these cylinders, which were made from essentially the same piece of paper, just different colored, how can they not hold the same amount of popcorn? How do they have different volumes? Use the formula for the volume of a cylinder to guide your explanation. The answer to this question will be discussed in our next activity, which is manipulating the height and the radius of a cylinder. Now, this final activity is very straightforward. We want to start with a cylinder that has a radius of 6 centimeters and a height of 3 centimeters. And we want to see what happens if we adjust the radius and the height of this cylinder by 1 unit, or 1 centimeter. And we want to see how this affects the volume of the cylinder. So again, we want to create a data chart. On our first row, which is already filled in, where we have a radius of 6 centimeters and a height of 3 centimeters, we have an approximate, that's what that squiggle line means, approximate. We have an approximate volume of 339.29 cubic centimeters. Now let's see what happens if we increase the radius by 1 centimeter. We substitute in our new radius and our height, so 7 and 3. In order to do this, we're going to substitute into our formula that we are using to find the volume of a cylinder. We do some simplification to where we get 147 pi. Now for this step, you can approximate pi to be 3.14. So now we have our answer of approximately 461.81 cubic centimeters. Now for the next cylinder, we're going to want to increase the height by 1 centimeter. That is, have a radius of 6 centimeters and a new height of 4 centimeters. We're going to use the same approach by substituting in these values to get the approximate value of 452.39 cubic centimeters. Which dimension had a larger impact on the volume of the cylinder, the radius or the height? So it's pretty clear from the data table that when we increased the radius of our cylinder, we had a larger outcome as far as volume than when we increased the height of the cylinder. So why do we think this is? Why is it that increasing the radius by 1 unit compared to increasing the height by 1 unit has a greater impact on the volume of the cylinder? Think back to our formula. Our radius is being squared, where our height is just being multiplied. Therefore, our radius being increased is going to have more of an impact. Now let's go over our objectives and our vocabulary that I listed earlier in the video. We went over how to calculate the volume of cylinders. We determined how changing one of the dimensions, the height or the radius of a cylinder, can affect the volume. And as far as vocabulary, we clearly discussed volume, what a cylinder is, the radius of a cylinder, and the height of a cylinder. Thank you for watching this video. I hope you enjoyed it. If you have any questions, please comment below. If this video helped, please leave a like. And for future videos, please subscribe. Thank you.